Greetings, students, and welcome back to this Wednesday's edition of Distant Learning with Mr. Wong. Today's lesson, 14.2, is on proportions, an extension of what we previously learned in a previous quarter dealing with ratio and rates. The homework is posted on eCampus. Download and complete. Make sure to show all work, and if working on a sheet of paper, ensure that you're copying the original problems. Let's continue. Proportions. How can proportions help you decide when things are fair? Well, the key idea for proportions is that it's an equation stating that two ratios are equivalent. Two quantities that form a proportion are proportional. The numbers example shows that 2/3 is equal to 4/6. The portion is read 2 is to 3 as 4 is to 6. Go ahead and pause the video now to write this down and the definition into your notes. Then resume the video once you've completed the task. Welcome back. Let's proceed. Let's determine whether the ratios form a proportion. Tell whether 6/4 and 8/12 form a proportion. Compare the ratios in simplest form. 6/4 can be simplified by dividing both sides by 2, resulting in 3/2. 8/12 can be divided by 4 on both sides, resulting in a simplified ratio as 2/3. The ratios are not equivalent because 2/3 is not the same as 3/2. So 6/4 and 8/12 do not form a proportion. Determine whether two quantities are proportional. It wants you to tell whether x and y are proportional. Compare each ratio x to y in simplest form. We have to go back to the previous lesson when we discussed complex fractions, a fraction with another fraction. So we'll be comparing 1/2 to 3 and 1 to 6. Are these proportional? Also, we'll be comparing 3/2 to 9 and comparing it to 1/6. And finally, we're comparing 2/12 to 1/6. Remember, it's not enough just to compare between two ratios. We have to compare across all the ratios to see if they find a match. The ratios are equivalent. Without having to set up a proportion, we can just take a look at the table and see by scaling. For example, if I were to multiply 3 times 2, I get 6. If I multiply 1/2 by 2, I'll also get 1. What about 3 times 3? That equals 9. What about 3 times 1/2? That's literally 3/2. And finally, let's scale from 6 to 12 by multiplying by 2. Does 1 times 2 give us the same value as in the x? And yes, it does. Again, we can compare fractions in a proportion, but also use scaling in the table to help us figure out if all the ratios are equivalent. So, x and y are proportional. Now it's your turn. Tell whether or not the ratios form a proportion. The easiest way for this, since we're not using complex fractions, is to use the similar example for question number 1 and actually simplify these to see if we get the same simplified ratio. Go ahead and copy these problems to work out, and then resume the video once you complete a task to check your answers. Pause the video now. Welcome back. Let's compare number 1. I mean, most of you guys already know the answer, because 5/10 is literally half. Yes, that's proportional. How about 4/6? Is that proportional to 18/24? If we simplified it, we'll see that it's no. We can also see if we can follow the golden rule and do the same thing on both sides to see if we get the same results. You see, the denominator 6 times 4 is 24. Is 4 times 4 then 18? If the answer is no, it's not proportional. How about this? Let's try scaling. 3 times 2 is 6. Is 10 times 2 5? No, it's not. Make sure that when you do things to both sides using the golden rule, that the direction is also the same. I'm going from 3 to 6 to the right. That means I must go from 10 to 5 to the right. Some may actually confuse this and write 3 as yes proportional because they see 3 and 6 times 2 and 5 times 2 is 10. But remember, direction matters. Now for question number 4. Let's reduce these fractions to its simplest form. The first fraction, 25/20ths, can be reduced by a factor of 5. 25 divided by 5 and 20 divided by 5 is 5/4. The same thing can be done for 15/12ths by dividing by 3. 15 divided by 3 is 5, and 12 divided by 3 is 4. 5/4 is equivalent to 5/4. Now on to question 5. Tell whether x and y are proportional. Well, let's use our trick to scale and multiply to get bigger and see if we can apply the same rule to both sides of this table. 1 times 2 is 2. 12 times 2 is 24. 2 times 2 is 4. 24 times 2 is 48. Now 2 times 3 is 6, and 24 times 3 is 72. Yes, it's proportional. Remember, we can use any ratio to compare to any other ratios, and we can't just go from 4 to 6. We can pick any one and scale correctly. Let's continue. We can also compare proportions by using something called the cross products. When we write the proportion A over B equals C over D, when we cross multiply, the products of A and D and the products of B and C are called cross products. And if the proportion is there, the cross products will be equal. For example, we're testing to see if 2/3 is equivalent to 4/6. If we made it into simplest form, 4/6 does become 2/3. But by using the property of cross products, we cross 2 times 6 and get 12. Do we get 12 also as a product of 4 and 3? Yes, we do. In this case, when using cross products, it's a more simpler and faster way to see if a proportion exists between two ratios. With algebra, it's A over B equals CD. Remember, it's a cross, not numerator and denominator. That's what's called cross products. You can do this in your work by actually circling diagonally the two terms. Let's try cross products in a couple of problems. You swim your first lap 4 laps in 2.4 minutes, and you complete 16 laps in 12 minutes. Is the number of laps proportional to your time? Method 1 is to compare the unit rates. You see, a unit rate has a ratio of 1. To do time per lap, we must divide the 4 laps by 4 to get the 1. Doing the same thing, dividing by 4 to the numerator in minutes, we get 0.6 minutes. Comparing 12 minutes and 16 laps, we also divide by 16 to get a single lap, and dividing by the same amount, 16, to the 12 minutes to get a rational number of 0.75 minutes per lap. 0.6 minutes and 0.75 minutes per lap are not equivalent. Now this seems like a lot of work. But what if we were to try method 2 and use cross products? Let's find out. We set up a ratio between the 2.4 as one ratio and 16/12 as the other ratio. Then we use cross products to find out if they're the same. By multiplying 12 and 4, we get 48. What about 2.4 times 16? Do we also get 48? As we can see, the resulting product of 2.4 times 16 is 38.4. Since the products when we cross are not the same, we already know that they are not proportional. Now there's also a third method. If we take 16 and divide it by 4, we do get 4 laps. By dividing 12 by a scale factor of 4, we should receive a result of 3 minutes, and since we don't, we also know this is not proportional. So the number of laps is not proportional to time. There are multiple methods for you to solve it, cross products being one of the simplest, but also if you know your multiplication facts and division facts, you can always scale to see if a proportion exists. Let's continue. On your own now, let's see if you can set up a proportion and figure out if these two ratios are proportional. You read the first 20 pages of a book in 25 minutes. You read 36 pages in 45 minutes. Is the number of pages read proportional to your time? Go ahead and pause the video and try and discover the answer working on your own. Then proceed to resume the video once you've completed the task. Welcome back. Let's check the solution. Yes, it's proportional. You see, by setting up the ratio 20 over 25 and then 36 over 45, we can cross multiply the 20 pages by 45 minutes and the 25 minutes by 36 pages. The result in both ratios multiplied in product should be 900, a perfect match. It looks like you're ready for the homework. Homework is 14.2, pages 610 through 611, questions 7, 14, 26, and 30. Click on the homework link for May 6, 2020 and download it complete. You can work on a sheet of paper, but always copy the original problem before solving. You may also print and work with the problems on the sheet of paper that's printed. Again, to receive full credit, do make sure that you're copying the original problem and showing the work, especially when you do cross products. Use a calculator to help you with your calculations. Submit the homework by taking a photo or attaching the document and emailing it to me. Until next time.